Hello all, in this video we will talk something about the RHS and other reason that to prove congruent at the same time so that we will mix them all up. Now, for teaching example 9.12, unluckily, I can tell you in this three right angle triangle, they are all congruent. So we must do congruent 2 times. And every time we will use 2 triangles to prove congruent. So how can we do and how can we choose? We will choose PQR as the linkage between it because you will see 1, 2, 3, 4. Only PQR have 4 conditions and the other 2 will only have 3 conditions. Why we use this one as a linkage? To link up A, B, C and X, Y, Z so that we can solve the problem easily. So let's look at A, B, C and PQR first. Okay, if I want to do it well, let's look at A, B, C and PQR first. And then we will see to do this triangle A, B, C and PQR. So obviously we can find out the 3 conditional. First of all, we have look at A, B, C only. We have right angle. The second one we have 2.5 cm. 2.5 cm. And the last one we have 1.5 cm. So it fulfills the RHS. So what's the meaning of RHS? You know that the RHS stands for right angle. We also have the right angle. And H, we want hypotenuse. That means the longer side in the right angle triangle. We have 2.5 cm with 2.5 cm. They're the same. So I think that H is fulfilled. And the last one is the SIDE side. So that means we have another side is called 1.5 cm. So I think that I can prove these 2 triangles congruent with RHS. So let us do it now. Okay, we have another question here, so we can do it at the right hand side. Now first of all we write down in triangle ABC and RPQ. Okay, we write down ABC and RPQ. Okay, we do it first. ABC, RPQ. And now we have the right angle. Right angle must be 90 degrees, so you must show it first. Angle ABC is equal to 90 degree equal to RPQ given. Okay, this is right angle. The next one with the hypotenuse, that means the longer side, you have AC will equal to RQ. So we have AC equals 2.5 cm equals RQ given. This is the second one. And last, we will say that 1.5 cm, that is BC will equal to PQ. So this is the last one, BC equal to 1.5 cm equal to PQ. So this time is once again given. So we will say that these 2 triangles are congruent. ABC is congruent to triangle RPQ. That one will be RHS. So we have the first triangle that we use. And then now we will use RPQ as the linkage to find out the congruent with these 2 triangles. So what can we do? Let us draw it one by one. This time look at X, Y, Z. This time I will also have the right angle. This one, once again. But unluckily, we do not have the exact because RHS, that means we have the hypotenuse, the longer side of it. We do not have exact, so we cannot use RHS. But luckily, we can find out that the 2 sides, 2 and 1.5 cm are given here. 1.5 cm, 1.5 cm, and 2 cm, 2 cm. You will see that the angle, the right angle is between these 2 sides. So this one I think is SAS. The angle between 2 sides. So this one is SAS. So I can prove it by SAS. So we can still find a way to solve the problem. So let us write down the part of it. Okay, let me move the leg a little bit so that you can see clearly. In triangle RPQ once again, RPQ, and triangle XYZ once again. We'll do one by one. QP is equal to 1.5 cm equal to ZY given directly. Next, the angle QPR or RPQ, you can say RPQ. This one you can omit the 90 degree is okay because this one is not RHS. So angle XYZ, this one is once again given. And finally, write down 2 cm, that is RP is equal to XY is equal to 2 cm. 2 cm XY. So this one is given once again. So 2 cm, I think this is a little bit, okay, 2 cm. So we can say, these two triangles are congruent once again. So RPQ is congruent to triangle XYZ. This time is SAS. So that means since triangle ABC is congruent to triangle RPQ and triangle RPQ is congruent to triangle XYZ, both of them are congruent. So you know that only one triangle can be, they can overlap to each other. So we can say triangle ABC is congruent to triangle RPQ and is also congruent to triangle XYZ. So we solve the problem like this. Okay, more than 10 steps, but it's really good for you to understand what is the meaning of the RHS and SAS. Okay, I stop here for 15 seconds. Okay, now this is your turn, and now I'll give you 1.5 minutes to do these questions. Quick practice 9.12. Okay, now if you cannot finish, just pause the video now and I will show the answer to you all now. Okay, now look at this three triangle. You will see the only linkage here is the XYZ because we have 1, 2, 3, 4, 4 condition. And then for the other two, we only have 3 conditional, but they are not same. So we will use ABC and XYZ and XYZ and DEF so that we can prove that they are congruent. So let's look at ABC. You will see this one is right angle, 6 cm and 6 cm, you have 10 cm. This is RHS. So I think that I proved these two triangles with RHS. But this one you will see, this one we do not have H, we do not have H and cm here, so we only have SAS here. So I will use SAS to prove these two triangles. So let us do it now. Okay, let's do it by one. We go to RHS first. In triangle ABC and triangle ZYX, okay, RHS first. So this one, angle BAC is equal to 90 degree is equal to angle YZX given R H 10 cm. So this one is BC equals 10 cm equals YX given The third one is the 6 cm. AB equals 6 cm equals ZY. So this once again is given for the last one. So I think that they are congruent. Triangle ABC is congruent to triangle ZYX. That one will be RHS. And next, what we are going to do is that we prove X, Y, Z, and DEF. So I cannot show it easily. So I hope you all can remember the picture. Maybe I put the picture here so that I can show the question easily. Okay, I want to show the other one is SAS. So the second one in triangle EDF and triangle ZYX. So EDF, ZYX. So we will do it one by one. Once again, this time is SAS. So we will have DD first. This one, DED is equal to 6 cm equal to ZY given. Okay, ED, ZY. Okay, we are given. And then we have the right angle, the angle. So this one is DDF. And this one is YZX. Angle DDF is equal to angle DDF equal to YZX. That one is given. Okay, so this is the second one. The last one is the XCM. So we have ZX and also the EF. So we have EF equals ZX. So this one is the last one. This once again, this one is given. So we can say triangle EDF is congruent to triangle ZYX. That one will be SAS. So we can say these two triangles are congruent. So because triangle ABC is congruent to triangle ZYX and triangle EDF is congruent to triangle ZYX, so we can say triangle ABC is congruent to triangle EDF is congruent to triangle ZYX. So we prove these triangles. Okay, this is the full steps of this quick practice 9.12. I give you 15-second pause first. Okay, now we will go to the last teaching example 9.13 and the quick practice for 9.1b for congruence, but not for similar. We also have similar here. So we are going to prove these three things. Okay, now let's look at this teaching example 9.13. We want to prove this congruent. We have 5 ways to prove congruent. First of all, SSS, SAS, ASA, AAS, RHS. We have five ways. So let's look at part A. So first of all, every time I told you, if you want to prove these two triangles are congruent, you must do is that you must find 3 conditions. That means you have found out 3 rows that you need to write down. So obviously you can see for part A, you will see 1, 2, 2. You have 2 conditions are given. That means only 1 conditional is missing. So we must find out which one you are going to use. You can say we cannot use the other angle because if the angle you have 3 angles, that means AAA. AAA is not a way that proves the congruent triangle because every time you will see here, for every time you prove the congruent, you must have at least 1 S. You have 1 S here, you write. So you must have the side. So you must choose which side you can use. For AB and CD, I do not know they are equal. For AD and BC, they do not know they are equal. But for BD equals BD. So I think that these two, I will use this straight line to prove congruent. So look at this one. We have 2 angles and 1 side. So we only have these 2, ASA and AAS. So which one you are going to use? For the angle, we have 2. In the middle is AB and CD. We do not have it. So this one is not ASA. This one is AAS. So we can prove part A is AAS. Okay, let us do it first for part A. In triangle ABD and triangle ABD, CDB, CDB, okay? We do it one by one, AAS. The angle DAB is equal to DAB, BCD given. The second one is angle ABD is equal to 90 degrees. You can write or you cannot write here. Angle CDB here for the second one. This one once again is given. The third one is the BD is equal to the DB. This one is called common side, the condition that we have. So we solve the problem directly. That means we will use this one. So triangle ABD is congruent to triangle, okay, I move it a little bit down. Triangle ABD and triangle CDB, that will be AAS. Okay, now let's look at part B. Okay, so 5-second pause first. Okay, now we will go to part B. Okay, now let's highlight which conditions are given here. One, we have the right angle, we have the one straight line, and the last one, you must know that this one must be the common side for these two triangles. Or you can use the vertical opposite angle, you can prove that they are congruent also. So that you can, this one is AAS, but I will choose the BC as the common side here, which is much better. So I think that this time I have two sides and I have one right angle. So once again, SSS, SAS, ASA, AAS, RHS. Okay, one by one first. So if I choose this one is, we only have one angle here. So we will not use ASA and AAS because we do not have two angles. Because we have one angle only, so also we will not use SSS because we do not have all straight lines are equal, okay? So the only way is the SAS and RHS. If I say that this one is SAS, that must be SA, we must choose BD or AC because we must make it as include angle. So this one is also wrong, but RHS, this one is okay because we have right angle, we have the hypotenuse, the longer side, and one S. So I will use RHS to prove part B. So let's look at the question and write down the answer. In triangle ABC and triangle DCB, okay, one by one, RHS, angle BAC, we must write down 90 degrees here because this is our right angle, and equal angle CDB given. Next, HBC equals CB, common side. Finally, we will use AB equal to DC. That one is given. So finally we have triangle ABC is congruent to triangle DCB. That one will be RHS. So we have finished the second part of it. And now I will give you 1 minute to find out these two, maybe 1.5 minutes to find out the answer of the quick practice 9.13 for both part A and part B. Okay, now if you cannot finish, just pause the video and we will go to the answer of this quick practice 9.13. Okay, now let's draw it one by one. First of all, we can count the conditional. First of all, we have straight line, we have a right angle, and obviously we have the common side here. Okay, now let's look at this one by one. SSS, SAS, ASA, AAS, and RHS. Okay, now let's look at one by one. First of all, we have two straight line, one angle. So I think that SSS is not wrong, ASA is not correct, and ASA and AAS is also not available in this situation. So what can we have is that this one RHS, we must have BC because we have the longer side, but we do not have it. So this one is not RHS, this one is SAS. I think that this is correct answer. And for the second part B, we choose once again SSS, SAS, ASA, AAS, and RHS. Okay, let's highlight three conditional. First of all, we have PR equal SQ. So PR equal SQ. This is a straight line. We have the right angle here. We do not have another angle. And we have the common side the QR equals to QR. So I think that these three conditional, okay, is we must consider. Choose straight line and run right angle. Once again, SSS, ASA, and AS is not valid here. So we can choose this SAS or RHS. Obviously, this one is RHS. So I will not choose SAS. So we'll write down the answer one by one. Okay, let's show you the answer. In triangle ABD and triangle CDB, you will see AB is equal to CD given S. And A is angle ABD is equal to angle CDB given 90 degree, but this one is SAS, no need to write it down. And finally, BD equals DB. This one is the common side here. So the reason here is called triangle ABD is congruent to triangle CDB. This one is SAS. And now we will go to part B. For part B, that one is RHS. So in triangle PQR and triangle SRQ, right angle go first. Angle PQR is equal to 90 degree equal to angle SRQ given. Next, the hypotenuse PR is equal to SQ given once again, given here. The third one is QR equals RQ. This one is the common side. So once again, all three conditional is okay. So we write down this is RHS. PQR is congruent to triangle SRQ. This one is RHS. So we can finish the answer here. And thanks for watching here, and bye bye.